Okay, guys, we are going to start out with sample exercise 5.3. And 5.3 says indicate the sign of the enthalpy change, delta H, in each of the following processes carried out under atmospheric pressure, and indicate whether the process is endo or exothermic. So A, an ice cube melts, and B, 1 gram of butane, which is C4H10, is combusted in sufficient oxygen to give complete combustion to CO2 and H2O. So simply this is saying, are these processes endo or exothermic? All right, so we need to look at each process to determine this. This whole chapter is about energy flow. So energy flow from a system to the surroundings or from the surroundings to a system. And the system is what we're going to be focusing on. That's what delta H is for heat, all that. That's what that stands for. All right, so looking at this, if we are going from a ice cube, which is a solid, to a liquid, which would be an ice cube melting, that requires energy. So anytime you're going from a more orderly state of matter, like a solid, to a less orderly state of matter, like a liquid or even a gas, this would be an endothermic process. Therefore, delta H, or the change in heat, would be positive. So that answers A. Ice cube melting, endothermic, requires heat. Letter B, if we are combusting 1 gram of butane in sufficient oxygen. So combustion reactions, this isn't going to be balanced, but just a little rundown. C10H4 plus oxygen yields CO2 and water. This process is exothermic because a lot of heat is released and a lot of light and heat. Anytime you're combusting or burning something, that's an exothermic process.